In this video, I introduce Bayesian inference for inverse reinforcement learning. Inverse reinforcement learning is used to find the reward function from expert demonstrations. To use Bayesian inference to solve inverse reinforcement learning problems, we first frame inverse reinforcement learning into Bayesian inference framework. The prior is a probability distribution of a reward function over the state action pairs. Initial prior can be any distribution, such as a uniform, if we don't know anything about the distribution of the reward function at the beginning, or it can be a specific function like a Gaussian, Laplacian, or beta. So based on the prior, agent start from his current state, takes the action A, and moves from current state to the next state. The likelihood is a probability of the predicted next state being the true next state. If an agent has a good prior, that means he understands the distribution of a reward function, or namely the environment. That means the agent has a more confident at this state S, selects this action A, and moves from his current state to the next state that is close to the true next state. Once we have a likelihood and the prior, then we can use a posterior to estimate the reward from the given trajectory. That means use this posterior to understand the expert behavior and extract the reward function from his demonstration. One of the most popular methods to estimate a reward function hidden in a trajectory is a maximum posterior. Next, let's graphically explain the Bayesian inference inverse reinforcement learning. At the beginning, let's start from an initial prior and the initial reward function together with the expert demonstration, that means training data. Use the maximum likelihood estimate to predict the trajectory. Use this predicted trajectory together with the expert demonstration to find the gradient of the loss function in the posterior model. So use this gradient to train the model to estimate the reward function. And then use this updated reward function to update the prior, and together with the expert demonstration to predict the next trajectory. Again, use this predict the trajectory together with the expert demonstration to find the gradient of the loss function in the posterior model. And use this way, we iteration by iteration, finally we get a convergence reward function. Once we get this reward function, and then with a new trajectory as an input to the posterior model, and the model can estimate the reward function R that is close to the optimal reward function. For more details, please check with this reference. Thank you. Bye.